if then. See, in if just we have written the condition. If the condition is satisfied, it is keeping those observations. In if then, first we can write a condition. If the condition is satisfied, only for those observations we can execute the statement also. Only for those observations where the condition is satisfied. Only for those observations we can execute the statement also. See, executes a SAS statement for observations that meet specific conditions. See syntax here. Data, new data set name. Set source data set. If any condition. So you can write condition here. Then SAS statement. You can write condition here. If this condition is satisfied, only for those observations I want to execute this statement. Then SAS statement. Only for those observations. Say now this. By using if then see, we can create new computed columns. We can update the data. Next we can create multiple data sets by using output keyword. Next we can delete the invalid data. We can delete. You see one by one. First of all, this one, to create new computed columns. So I have one data set in SAS user, just here EMP1. Just I have prepared this one from EMP data only by using keyboard option. So print the EMP data. So print data is equals to employee1 run. See, we have only two variables here. Employee name, SAL. Two variables. Employee name, SAL. Now based on SAL variable, here I want to create a new computed column bonus. So we don't have here bonus variable. I want to create that one based on SAL variable. So these are the business rules. See requirement. If salary less than or equals to 1500, for those employees I want to give the bonus 500. If salary between this range, for those employees I want to give the bonus 1000. If salary greater than 2500, see for those employees 2000. Data, new data set name, employee2. Source is employee1 data set. Okay, if salary, we can use words also, less than, otherwise less than or equals to 1500. Then for those employees I am giving the bonus 500. If salary greater than 1500 and salary less than or equals to 2005, then for those employees I am giving the bonus 1000. If salary greater than 2500, then bonus is equals to 2000. So first of all I am writing the condition. If this condition is satisfied, this is the statement. Okay, this is the condition. If this condition is satisfied, then this is the statement, like this. See, I have created new column, bonus. And check here, salary less than 1500. So it's showing bonus 500. So here salary between the range 1500 to 2500. See bonus 1000. So here salary greater than 2500, showing the bonus 2000. So like this we can create new computed columns. Suppose I want to create one more column. Total salary is nothing but salary plus bonus. I'm creating this new column. Total salary. Nothing but salary plus bonus. This one plus this one. We can create new computed columns. Next, to update the data. Suppose class data. This is the reference variable, gender. So here we have two groups, male, female. Male data, female data. So I don't want all letters here. Just I want to show instead of male capital M. Instead of female I want to show capital F. That's all. I want to update the data here. See, like this. In the class data set, in the gender variable, we have observations like this, male, female. But in the new data set, under the gender variable, see, in the place of male, I want to show capital M. In the place of female, I want to show capital F. Data, new data set name, class file, class. If gender is equals to female, then gender is equals to F. We are writing the condition. If this condition is satisfied, then this is the statement. So I want to update the observations like this. So execute. See. So in the place of male, just it's showing capital M. In the place of female, just it's showing capital M. That's it. We can update like this. Okay, next, one more requirement. To create multiple data sets by using output keyword. The same class data again. So same, this is the reference variable, gender, male data, female data. See the requirement. Class is the source data set. Here in gender variable we have male data, female data. Now based on class data set, at a time I want to create two new data sets. Class underscore male, class underscore female. In this data set, under gender variable I want to keep only male data. So in this data set, under the gender variable I want to keep only female data. Data, new data set name, two data sets. Source is the class. First we can write the condition. If gender is equals to male, then output class underscore. So output is the keyword. So this is the condition. If gender is equals to male, if this condition is satisfied, then keep all those observations in this data set. So this is the data set name. See this one, class underscore male. Next, then output. See if this condition is satisfied, then keep all those observations in this data set. So output is the keyword. So no need to use equal sign also. Just we can write output. If this condition is satisfied, then keep all those observations in this data set. That's the meaning. Okay, see here. Now we have only these two data sets, class EMP in SAS. Okay, execute this. See, two data sets created at a time. Class underscore male, class underscore female. See the outputs. Class underscore male. So we have only male data. So from gender variable only male data. Observe this one. So here we have only female data from the gender variable. So we have separated based on the condition. So we can create multiple data sets, means more than one data set here at a time by using output keyword. Next, fourth one, to delete the invalid data. Okay, now I'm doing one project, neighbor project. So I got data in an Excel file, neighbor data. Okay, this is the data here. So I need to import the data. After that, we have SOP, standard operating procedure. So here for variables, we have some ranges, valid ranges. See, for the age variable, this is the valid range, 30 to 75 years. Means if any patient is having less than 30 years or greater than 75 years, they are not useful for our analysis. So like that, see, for all variables, you can find the ranges, valid ranges. Okay, now I want to do this project. Okay, just beginning. So I want to import the data. So we can write the program. Proc import data file. So when you have files in the subfolders, you can do like this. Right click on the file, properties, copy the location. This is simple. File name, Sniper data dot xms. Out is equals to Sniper dbms x. Okay, Sniper dataset created. These are the variables: name, age, sex, so on. See how many observations are there? See, we have 407 patients data here. 407. 400 data is nothing, just null values. Totally 407 patients data. Okay, here age is the reference variable now. For age, we have a valid range. See this one, 30 to 75 years. This is only the valid here. As for the SOP, standard operating procedure. Sometimes they may call it as format file. So as for that, age variable valid range is this one, 30 to 75. First of all, let me find out, is there any invalid observations there or not in the data set. So first of all, to find the invalid data. So we can write an example here. Data age underscore invalid. Means according to the age variable invalid data. I want separate. Source is Sniper. If age greater than less than 30 or age greater than 75. So here some invalid data is there, 19 observations, because the ages are like this, greater than 75 and age less than 30 also. Invalid. So okay, as per the client requirement, now I want to delete this invalid data because these observations are not useful for me for analysis. So see how to delete the invalid data permanently. So here we can write the delete, and here I will write the name neighbor. So the same name I have given means I don't want to create any new data set. From the source data set itself, I want to delete these observations permanently. From the source data set itself, I want to delete these observations permanently. So I have given the same name. So now here in the age variable, you can have only the valid data. Only the data between 30 to 75. Even 30 is also valid, 75 is also valid. No problem. But if it is less than 30 or greater than 75, then only invalid. So here we have only valid data now. So only valid. So this program is useful to find the invalid data, and this one is useful to delete the invalid data. So to delete we are using this keyword, then delete. Delete is the keyword to delete the invalid data.